Yesterday we were discussing about Mann-Whitney test. When do you use Mann-Whitney test? Yeah. We use Mann-Whitney test when the data that we have is not normal. Whenever there is no normality, that is when we use Mann-Whitney test. Now, right, while doing Mann-Whitney test, we have looked into the p-value, which is nothing but 0.2248 in this case. It's highlighted using this arrow. Here p is high. If p high, we know that null fly, that means we have to accept null hypothesis, which says medians are the same. So there is no reason to believe that the additive is different. But when the data is not normal, we have to go back and check few things. What are those few things? Here is point 1. Since the data was not normal, the cause of non-normality was investigated. Why is data not normal? You'll have to investigate that. And during your analysis, maybe you have found that the first data point for with additive was wrongly entered. This value should have been 20. Right? If this value is 20, we can proceed with the analysis. If the data were truly non-normal, analysis would stop here. If a data was not normal, truly, I mean there were no such issues, wrongly you have not entered anything, in that case you stop here, Mann-Whitney test. Oh, medians are not same, that means there is no reason to believe additive is different. That's it, you stop there. But if data is not normal, you should not directly, jump in with the conclusion saying that data is not normal. You have to just ask yourself, did someone enter data wrongly? Right? Or are you putting few values in one unit and another values in another unit? For example, maybe you have few values which people have measured in kilometers, few values in which people have measured the distance in miles, right? Quite possible. So you need to check those kind of things. And suppose there is any such discrepancy, you need to correct it and do the analysis once again. So here, it's clearly mentioned that the first data point for with additive was wrongly entered. So let me open with additive thing. I think that is AT test. Let me open that mini tab and then show you. It's a different thing. Still coming up. It's the same. I have zipped the entire thing and then I have sent it across. Alright. So with additive and without additive, people say that because of analysis, the first point should have been 20 instead of 16. So I replace it with 20. Now let me do the normality test for both of them independently. First without additive. Without additive, I think it was already normal. P-value is greater. So data is normal. Let me go back to the worksheet. Let me select with additives. Normality test with additive. Look at this. Earlier this was not normal. Now the moment I changed one data point from 16 to 20, data all of a sudden becomes normal. The p-value shows as 0.167. It's greater than 0.05. Hence we say that data are normal. So if data are normal in both the cases, then what do? Let me go back and show you that. Where are we? Okay. We are comparing two populations with each other. We checked for the normality. If the data wasn't normal, we would have gone with Mann-Whitney test. Right? Let me highlight that with a pen. My system got stuck, I think. 1 second. Mm, what has happened? Okay, now it has gone. All right. This is the Mann-Whitney test. If data wasn't normal, you would have gone with Mann-Whitney test. But since the data are normal, you look into whether external conditions are same or not. Now data are normal. So if data are normal and this, you go with paid t-test. So let us see which test we have to actually use. Okay. Select this. My system is also playing with me. All right, I think yes. Normality test we have done and we have found that for with additive, it's normal now. If data are normal and the external conditions are the same. Yeah, in this case, external conditions were same because we are taking the same set of vehicles. We are first running it without additive and recording the mileage. And same set of vehicles, we are adding the additives and recording the mileage. Then what do? We go to stat, basic statistics, do two variance test. Because that flowchart says you have to do, you have to check for two variance also. Right? You do two variance test only if the external conditions are not same. So here we are assuming that what if these two are different set of vehicles? These 10 are different vehicles, these 10 are different vehicles. That is the case, what do you do? If that is the case, the second step would be go to stat, basic statistics, two variances. So let me do that. Stat, basic statistics, two variances. What happened? So both samples are in one column? No. Each sample is in its own column. First one is without additive, second one is with additive. Yes, it is told. Now Anuj, are you able to hear me? Okay. So let me just repeat this quickly. If these 10 vehicles without additive are different vehicles in comparison to with additive. So if these two are 10 different vehicles altogether, then you also need to look into two variance tests. So that is what I'm doing now. Two variances. Are both the samples in one column? No. We have each sample in its own column without additive and with additive. So after doing that, let me check the options. Options are fine. We are just checking whether the variances are equal or not. Or if you want, I can change it to variance. Do we need any additional graphs? No, summary plot will do the job. Click on OK. Here is what I got. So this is how you need to interpret this. Okay. If data was assumed to be normal, then you go ahead with bonnet test. There are two tests. You are getting p-value for bonnet test. You are also getting p-value for Levene test. Yeah. So Levene test, you use it when data are not normal. Bonnet test, you use this value if data are normal. Simple. So look at this. We use p-value corresponding to the bonnet test because we know that the distributions are normal. If distributions were not normal, then we would use the p-value for the Levene's test. What does p-value say? P-value is 0.376. If p is high, null fly, we accept null hypothesis. What does null hypothesis say? Variances are equal. That means we are telling that variances between without additives and with additives is the same. Next, once you're done with that, you'll have to do two sample t-test because variances are equal. Let me go back to the worksheet. Stat, basic statistics, two sample t-test. Without additive and with additive. Let me see whether any options need to be selected, not required. Assume equal variances or not. Should you check that option or not? It depends again on the flowchart. Let me take you back to the flowchart. Here is a flowchart. So by looking at the flowchart, Anuj, can you just tell me whether I have to select that option or not? Let me put it in slide mode. So we found that y1 and y2 are normal. Then we checked for external conditions. We found that those are different vehicles, so the external conditions are not seen. Hence, we have checked our variances equal. And we found that variances are equal. So now tell me whether I have to check that option, assume equal variances, or I should not check that. I should not check that is what you're telling. Why shouldn't I check? Which box are you referring to? This one? Because we have proved that variances are equal. If variances are equal, what should you use? 2 sample T for equal variances. For equal variances. So if the variances are equal, you check that option, assume equal variances. Alright. So let me take you back. Yeah, here you need to check that option, assume equal variances, because we have just proved that variances are equal. So we will have to check that option. Yeah, probably we can go with a box plot. Okay, my bad. No, they are not in one column. Each sample is in its own column. Oh, I've selected again with additive here also. It's without additive and with additive. So these things are actually pasted here also. So let us see. So what is the p-value coming up to? 0.097, which is greater than 0.05, which indicates we need to accept null hypothesis. Adding additive does not increase the mileage. That is what you conclude at the end, because mean mileage is the same. Null hypothesis says mean of without additive and mean of with additive both are same. Hence we are going with two sample t-test. Alright. Case 2. Suppose the external conditions are the same. Yeah, let me take you back to that sheet. So this flowchart would be like a Bible for you. Suppose external conditions are same, Anuj. Then what test are you going to use? My question was, if external conditions are the same, there are two vehicles. I have to check the mileage without additive and with additive. In earlier scenario, we have assumed that external conditions are not the same, and we have done two sample t-test. Now my question is, if the external conditions are same, which test are you going to use? You can look into the flowchart that I'm showing, and then, yeah, data are normal. I have proved it. Then data is normal. Additive and without additive, we have proved that. Now the only changes here, external conditions. First, we have assumed that external conditions are not same, and we have done this. If we assume that external conditions are same, then which test are we going to use? Paired t-test. Correct. Exactly. So let us do the paired t-test. Here it is, paired t-test. The most important thing is composing your hypothesis. Mileage is same for both with and without additive. Mileage increases after adding fuel additive. Yeah, these two things. Let us do let us do that hypothesis testing. The connection is again lost. Hey Anuj, now are you able to hear me? Okay. So I'm doing the paired test now. Paired t-test. Yeah. All right. So each sample is in its own column. So I'll select without additive and with additive. Let me go to the options. Here there are two things. We want to check whether without additive and with additive is different or not. We want to find out whether mileage of with additive is greater than without additive or not. So I want to check this. That is a difference less than the hypothesized difference. Difference means sample 1 minus sample 2. Sample 1 is without additive minus with additive. It should be less than 0. All right. Do we need to check anything? Let me check all three. Just like that for additional analysis. That's it. All right. Look at the p-value. It is 0.032. So what do you conclude by looking at the p-value? Are you going to accept or reject null hypothesis? All right. We reject null hypothesis. Let me also change here because we always speak in those lines. We reject null hypothesis. Adding additive does increase the mileage. That is what you are telling. Yes, adding additive actually increases the mileage. Now the paired T is more powerful, and for the same data set, it can detect minor differences. While two sample t-test would conclude there is no difference. That is why you need to check into that external conditions, right? And then do the appropriate test. Sorry, that was two-pair test. Just because a hypothesis test shows that adding an additive makes a difference statistically with respect to mileage, it does not mean we can start implementing that recommendation right away. Let's say the mean improvement in mileage with the additive is 1.85 miles per gallon. If the cost of gasoline is $4 per gallon and each gallon gives us 30 miles, then this improvement saves us $0.23 for each gallon of gasoline. Yeah, it's going to save you $0.23 if you add additive. But what is the cost of additive? Cost of additive is $0.5 per gallon. Then what will you be doing? You're gaining $0.23, but you're spending 0.5. Is that a good improvement? No. So in this case, even though the improvement in mileage is statistically significant, it is not practically important as we are losing money to add the additives. Hence, in addition to statistical significance, we also need to consider if the improvement is practically beneficial for us or not. Next thing is ANOVA, analysis of variance. ANOVA can be used to test the equality of means when there are more than two populations. ANOVA can be used with one or two factors. If only one factor is varying, then we would use one-way ANOVA. Here is an example for one-way ANOVA that is given already. So let me highlight. Suppose we are interested in comparing the mean performance of several departments within your company. Here the only factor is the name of the department. You have only one factor, but you have various populations. You have 7 populations, or you have several departments, so several things. If there are two factors, we use a two-way ANOVA. Example, one factor is a department and the second factor would be the shift. Day shift, do people work in day shift or night shift? There are two factors once again. There are few assumptions, however, for ANOVA. The tool assumes that the response approximately follows a normal distribution. That is the first assumption. All the inputs should have the same variance in order to use ANOVA. That is the second assumption. So let us do this. Let me open this example of I need to open this example. One-way ANOVA. Let me see whether it's written in that way. Yeah, we have it. One-way ANOVA. Yeah, so these are the 5 circus groups and what is provided about them. Yeah, data of cost of tickets sold in thousands in a show for a month are tabulated for 5 different competent circus groups. Check if their means are different or same. Yeah, that is the task that is assigned to you. So what is a factor? Yeah, all right, Anush. All right. So the factor here is circus group. Circus group is a factor. How many levels do we have? We have 5 levels. Yeah. Why am I saying 5 levels? Because we have gem, Joyride, Starlight, Fancy and Fun. And I'm telling we have 5 circus groups and those are the 5 levels that we have. So let us do this. We have to first check the normality, whether the data are normal or not. So here is the data. Let me close the other two. All right. So I go to stat, basic statistics. If I do normality test, it's good, but I need to do for all 5 independently. All right, let us do in that way. And also we will do one in one easy way. Is data normal, Anuj? Yes. Here is data normal for Joyride. Yes. For Starlight. Perfect. Fantasy. Yep. And for Fun, it's normal. It also shows here whether data are normal or not. Just below that. All right. Now, instead of doing independently for everything, I can even go to basic statistics, click on graphical summary, select at one go from gem to fun and click on OK. It will generate 5 different plots. I believe this is the easier way. I can, but it doesn't say whether it's normal or not. You need to look into p-value. Yeah, for fun it is normal. For fantasy, yes, it's 0.33. It's greater than 0.05, hence it's normal. For Starlight also it's normal. For Joyride also it's normal. And then for gem also it is normal. Fine. You conclude that data are normal. If data are normal, then the second test for ANOVA is check for the variances, whether the variances are equal or not. So go to stat, ANOVA, test for equal variances. Response data are in one column for all factor levels. No. Response data are in separate column for each factor level. Correct? Yeah, use test based on normal distribution. We just select this option because we have already proved that it is normal. And then summary plot is fine. Then click on OK. By looking at the p-value, what do we conclude? Here is a p-value, or you can look into this image also. We reject null hypothesis. So what do you conclude about variances? We are doing test of variances, right? So what do we conclude? Yes, we conclude that variances are not equal. We conclude that variances are not equal. Fine. Look at these variances and look at these confidence intervals. If you see the confidence intervals of Fun, Fantasy, Starlight and Joyride are overlapping with each other, with exception to Gem. So variance of Gem versus the other are significantly different. So what you need to do is just remove Gem and see, because we believe by the look of this, it sounds like Gem is an outlier. Yeah, so these four are more or less looking the same. Confidence intervals are overlapping. So that is how we proceed actually. From this also it is clear that gem, oh my, 1 second. All right. So from this we conclude that it's 0.0 or 0.001. Hence variances are not equal, right? But in reality, we are not going to stop here. We are going to exclude the gem and then see how it works, how ANOVA works. All right, let us do that now. I go back, I exclude gem, I go to stat, ANOVA, test for equal variances. Let me remove gem. Let me select from joyride to fun. Click on options. Yeah. Okay. Now look at the p-value. Now tell me, what will you do? Janusz, are we going to accept or reject? Yeah, we are going to conclude that the variances are equal. That is what we are going to conclude. All right. If variances are equal, then comes the next step of performing your ANOVA test. We actually come up with, yeah. All right. All right. Okay. So equal variances is done. So let us do one-way ANOVA test now. Because if you follow that flow chart, this is how you're going to arrive. You'll first check for the normality. If the data is normal, you check for variances. If the variances are equal, then you proceed with ANOVA. So let me go to stat, ANOVA, one way. Response data are in one column for all factor levels. Now, response data are in separate columns for each factor level. Options, yes, we are assuming equal variances because variances we already put are equal. We want two-sided things. Perfect. Oh, there are many things. Tukey, Fisher, Donut. Out of scope for now, but the moment we get into master blood, we are going to discuss all these things. All right, let me click on simple. Okay. We are interested basically in the p-value. What is the p-value here? 0.000. What do you do? Do you accept or reject null hypothesis? You reject null hypothesis. So you're telling all means are equal is something that I'm rejecting. I'm telling that at least one mean is different. Yeah, that is what you conclude. All right. So p-value here was less than 0.05, which indicates that we accept null hypothesis. Yeah, we get R squared value also. I mean, these calculations aren't important. R squared value and all we will discuss once we move to regression. That is the next topic actually. Pooled standard oh my god, there's some problem. Serious problem. Are you able to hear me now, Anuj? Perfect. So there is something called as within group variation and between group, right? Within group variation means within the starlight, what is the variation? Within the joyride, what is the variation? Within fun, what is the variation? Within fantasy, what is the variation? So that is called as within group variation. Now between group variation means what is the variation between starlight, joyride, fun and fantasy? Yeah. Then we have another such example that we have. The number of road accidents in a month are recorded for 12 months. Find if the average number of road accidents are the same across all cities. So you have one factor, city name. But how many levels do you have? 5 levels. 1, 2, 3, 4, 5. Atlanta, Bismarck, New York, San Diego and Phoenix. So you have 5 cities. 5 levels. How many factors? One factor. City name is one factor. Alright, let us open this. Not sure what the name of this would be. We do have ANOVA. Just give me a minute. Let me figure out. Just checking 1 second. Okay, it's called as test for equal variances. Isn't it? All right, just a minute while I open that. Yeah, it has come up. So first test is we need to check for the normality. I go to stat, basic statistics. Either I can click on normality test and do it for each individual, or I can click on graphical summary, select from Atlanta to Phoenix. At one go, I can select. Phoenix data is normal. San Diego data is normal. New York data is normal. Bismarck data is normal and Atlanta data is normal. So data are normal. Next, what do? We test for equal variances. We go to stat, ANOVA, test for equal variances. Response data are in one column or of all factors? No, are in separate column for each factor level. Yeah, test based on normal distribution. I select OK. By looking at the graph also we can make some statements. San Diego is slightly different, hence the p-value is less. So you're telling that p-value is less. Variances are not equal. Yeah, but San Diego, if you see, it's slightly different from the rest, right? So let me see whether I can retest this by just removing San Diego and see how it works. Now it looks like things are in tact and it's 0.414, which means you are accepting that variances are equal. If variances are equal, then but we have to actually ask ourselves, is San Diego different really or not? Though it's appearing like that, it's different. There comes your actual analysis. You'll do some research. You'll try to identify what data this is, right? A number of road accidents. Is San Diego a very small place? Are the number of vehicles very less in San Diego? If that is the scenario, then probably you'll remove it. But if San Diego is also equally big in comparison to Phoenix or New York or the other things, and if it has equal number of vehicles, then you consider that. The variances are not equal, and then you go with A norm, A no M. This is a different test. You'll probably go with this, right? But even before going that, you just want to cross check yourself. Is San Diego a small place, less number of vehicles in comparison to the other 4 cities? You check that. And only then you take a call whether you have to remove that or not really. All right. Suppose we have removed that. Response data are in one column for all factor levels. No, they're in different columns. So once again, I need to select only till here. San Diego we are not considering. Options. Yeah, we are assuming equal variances. Yes, that's already selected. One way means anyways it's assumed. All right, let me go to the p-value here also. And the p-value shows as 0.001. What does that mean? We are going to reject null hypothesis, and we are going to make a statement saying that, where is that exercise here? We are going to make a statement that number of road accidents are not the same across all cities. They are different. So you just make that statement. All right, Anuj, we will stop here. Tomorrow or today evening when we connect,